10.5, probability of independent and dependent events. Hopefully you guys know what independent and dependent mean, but we're going to talk about it in math terms here in just a minute. Remember that probability is always the successful outcomes divided by the total outcomes that are possible. So, an independent event is an event where the outcome of one event does not affect the outcome of another event. So not thinking mathematically, can anyone think of two independent events? So separate, they don't affect each other.
Wait, they do. Never mind those.
Sure. Going to Disneyland, going to Six Flags, total separate events. That's fine. That works. Okay, dependent events is where the outcome of one event does affect the outcome of another event. For me, what I think about independent events is like doing your math work and paying attention in class and the grade you get on a test. Those are dependent. If you don't pay attention in class, you don't do your homework, then you're going to get a bad grade, right? Like that's just going to happen unless you're a genius. And yeah, we'll just leave it there. Okay. So, okay, probability of independent events is probability of A and B, you just multiply them together. Dependent events is you take the probability of A and then you multiply by B once A has occurred. For instance, like remember the bags of marbles, okay? That would be a dependent event because you draw one marble out and that affects the probability of the next one because that one marble has been taken out. Does that make sense? So that's why it's B once A has occurred. Okay, so be careful. If a word problem uses the word and, you're going to use multiplication. And sorry that my type is off here. So this bugs me, so I'm putting multiplication over here. Even though it's right there. Okay, so if it's using and, you use multiplication. If it's using or, you will use addition. Remember with or too, you need to be careful if you have to subtract out something where it overlapped. And we talked about that yesterday. So in this first example, all we're going to do is just state whether it's an independent or dependent event. Okay? The color of a car selected at random and the type of transmission selected at random. Are those independent events or dependent? Like independent, because you can pick a red car and that red car will come in a manual or automatic transmission. Okay? It's not like if you have a red car, it has to be manual, right? So they're totally separate. You can pick what color car you want and what transmission you're getting. They don't affect each other, okay? So that's independent. If you have a cell phone out right now, you need to put it away, put it face down on your desk. Okay. B. A letter of the alphabet selected at random and then another letter selected at random. So you're choosing a letter from the alphabet. You've chosen it. It's no longer in the alphabet, and then you're going to choose another one. Is that independent or dependent? Dependent, because once you choose a letter, you can't choose that one again. Okay? So depending on what you chose will change your outcome. Okay, hopefully you get this one right. Completing your homework and earning your grade on the test. Good. Okay, rolling a die and getting a 1, and then rolling the die and getting a 3. Independent, because you could roll a 1 and still get another 1, right? When you roll die each time, it's an independent event, so that's independent. Okay, questions so far? All right, example 2. A card is to be selected from a deck of 52 cards. What is the probability that it is a black card or a 10? First of all, when we see or, that tells us we are going to add. Very good. Black card. How many black cards? 26 out of 52, right? Clubs and spades are black. And then how many 10s are there? 4 out of 52. And remember, when we're adding, we need to subtract out anything that overlaps. So did we have any overlapping? How many? So we're going to subtract out 2 over 52. So when we add there, 26 plus 4 is 30, minus 2 is 28 over 52. And can I reduce? They end in even numbers, so I know I can at least start by dividing by 2. And I get 14 over 26. And can I reduce again? Perfect. All right. Okay, example 3. On these next examples, we're going to state whether these are independent or dependent events and then actually find the answer as well. Okay, a drawer contains 3 red, 4 green, and 5 blue paper clips. 1 paper clip is taken from the drawer and then replaced. Replaced and not replaced are keywords that you should circle or underline when you're doing your work. Another paper clip is taken from the drawer. What is the probability that the first paper clip is red and the second is blue? First of all, what is our total? 12. Okay. Now, do you think this is independent or dependent? Why is it independent? Because you're putting it back in. You could choose that same paper clip again, couldn't you? Okay, so the first one is red. So how many reds are there? 3 out of 12. We take out a red and then we put it back. And the second one is blue. How many blue? 5 out of 12. Because we had put the paper clip back, you still have 12 in there. Can anything reduce? Good. So 3 becomes 1, 12 becomes 4. And can anything else reduce? Nope. So we have 5 over 48. And that's our answer. Questions? All right, example 4. Again, we have a drawer containing 3 red, 4 green, and 5 blue paper clips. 1 paper clip is taken from the drawer, and it is not replaced. Again, pay attention to that. Another paper clip is taken from the drawer. What's the probability the first is red, the second is blue? Is this independent or dependent? Dependent. Why is it dependent? Exactly. It's your chances are going to change because you've taken one out. So what's the probability of having a red? 3 out of 12. And then a blue. Good. 5 out of 11. Because we didn't take a blue one out, we took a red one out, right? So there's 1 less red, but there's still 5 blue in there, but there's 1 less total. Okay? Are we good with that? Can anything reduce? Yeah. Okay, so we have 1 over 4. Anything else? No. So we have 5 over 44 as our answer. Okay, so far so good? All right, example 5. You have 10 coins. Of those coins, you have 3 dimes, 5 quarters, 2 pennies. The coin is selected and replaced 3 times. Bless you. That means it's independent or dependent? Independent. Very good. Okay, find the probability all 3 coins are dimes. So we're going to pull out a dime 3 times. So the first time I am getting a dime, how many are there? 3 out of 10. I put that dime back in and I do it again. What happens? 3 out of 10. And then I'm going to do it a third time, which will also be 3 out of 10. Dilly, why don't you try paying attention, okay? Okay. So then we multiply it all, and what do we get? That's the answer. Good job. Okay, I'm going to give you about 20 seconds to do B on your own. I need to have the whiteboards on your guys' desks. All right, so is this one independent or dependent? Why is it dependent? It's not being replaced, so depending on what you take out, you can't get that again. Okay, so again, 3 times. So the first time I'm taking something out, what is the probability of getting a dime? Okay, 3 out of 10. We take out 1 dime. How many dimes are there now? 2 out of 9. We take another one out, and now we have 1 over 8. Okay, look up here. The answer is 1 over 120. Some of you did not get that. So check to see what's happening here. So we can reduce. 3 becomes 1, 9 becomes 3. I can divide 2 into 8 or 10. So I'm just going to go, 2 goes into 2 once and 2 goes into 10 5 times. And I multiply. On top I have 1. On the bottom 5 times 3 is 15. And 15 times 8 is 120. Are we good? Yes? Okay. All right. You need to draw in like your little tree here. So these connect like this. These connect like this. Yeah, you could draw some lines under these. Sorry. Okay. All right. John is choosing between 2 majors in college, either architecture or engineering. His preferences in each area are shown. If the probability of architecture and commercial is 72%, find engineering. Okay? So we're going to actually end up finding what the probability of architecture is and the probability of engineering. When you're finding probability, we are going to add or multiply. Multiply, okay? You're only going to add when you see the word or. In this problem, I do not see any ors, okay? I only see ands. Okay, when you are finding probability, you're going to multiply the 2 things together. So right here, it's telling you that architecture and commercial is 72%. So if we go down here, we have architecture and commercial. Okay, do you guys see that? Do I know what architecture is? No. This is my X. I know that commercial is 90%, and I know that when I multiply them together, it equals 72%. Okay, so I'm going to end up changing these to decimals. So that means I'm going to have 0.9x equals 0.72. And so to find the answer, we divide by 0.9 to both sides. And we get x equals 0.8. Or as a percent, it is 80%. So architecture is 80%. Now, these 2, he has to choose architecture or engineering. He's going to choose one of those 2. So if this is 80%, this has to be 20%. Okay, now to just double check you understand, if I said, what is the probability of him becoming an electrical engineer? So that'd be engineering and electrical. How would you find that answer? What would you do? An electrical engineer. Yeah, so on this one, we already have all the data, don't I? For engineering and electrical. So all you're going to do to find those together is you just multiply them together. So you would do 0.2 times 0.6. And what is 0.2 times 0.6? 0.12, which is 12%. So there's a 12% chance he's going to become an electrical engineer. And that's the same thing I did here. I multiplied x times this, and we knew what the answer was, right? Okay. Somebody asked me a question about this. So we didn't know what architecture was, right? So I gave that an X. But they told us that the probability of architecture and commercial, so architecture and commercial is 72. So I knew that if I go X times 0.9, which makes 0.9x, will equal the 0.72. And then I was able to solve and get 0.8, which is 80%. Mm-hmm. Okay. Any other questions? All right, example 7. Okay, most of the time on your homework when you have these charts, they're not going to give you these totals. See how I have the total columns? Most of the time you will not see the totals, and you have to make your own totals. So I just want you to notice, like, this part is like basically the chart you're going to get. Okay, and then you would end up making all the totals. So you always like want to add your columns and your rows and then get the total for the entire chart. Okay? So basically in this thing where they asked people questions, there were 24 people that they talked to. Okay? So there were college grads, non-college grads, and there were men and women. All right. So when you're finding probability, there's this special question. It says, what's the probability that if you randomly pick an employee, it will be a female given that you pick a college grad? Okay, this given is a special type of probability. Okay, when you have this one, and again, probability event B given event A. This is how it looks on paper. B given event A. It's like a line like that. Okay, that means B given event A. You find the answer by finding the probability of A and B together. So in this case, I'm going to find the probability of female and college grad. Okay, that's what's going to go on the top. It's where they both overlap together. So how many females and college graduates are there? 12. So 12 goes on the top. And then you always divide by whatever comes second. Okay? So on this one, it's going to be the probability of a college grad. So again, the bottom is always the total of the second thing. So in this case, see how college graduate came second? That's what I'm talking about. So the total of college graduates. So what is the total of college graduates? 19. And if you could reduce, you would, but you can't. So that's your answer. So if I give you another one, what is the probability? I'm just going to, like, it's this whole same sentence, but this time I'm going to say male given that you pick a non-college grad. Okay, so you're going to find that answer. Male given that you pick a non-college grad. You can actually show me this one on your fingers if you want to. Yes. 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 Good, good, good. Okay, so male and non-college grad, how many are there? 2. Right here. Men, non-college grad, there's 2 of them. Divided by the total of what came second, so the total of non-college grad is 5. 2 over 5, and that can't reduce. Okay, example 8. If the probability of event A given event B, so this is one of those problems again, A given event B is 0.6, and the probability of event B is 0.4, what is the probability of events A and B happening together? So you're using this formula basically, and you're going to find whatever's missing. So you have like your fraction where you have A and B divided by the total of the second equals your given part, right? So they said if the probability of event A given event B is 0.6, where would the 0.6 go? Where? It's telling you the probability of event A given event B is 0.6. It's going to go in the answer part, okay? Then it says, and the probability of event B is 0.4. So you know how B came second? That's the total of that one. So that 0.4 is what's going on the bottom. And they want to know what's the probability of events A and B happening together. So we don't know them together, so that on top is your X. Right. Okay. So then how do I end up finding the answer? What would I do? Good. Multiply by 0.4 to both sides. Those cancel. We get X equals 0.24. And that's your answer.